Very good morning to everyone. Today I am going to start the basics of heat transfer. First of all, we should know what is heat transfer and how it is different from thermodynamics. Heat transfer is a science which deals with the flow of heat from higher temperature to a lower temperature. That means heat is a form of energy and it is getting transferred. So the heat energy is getting transferred, and this particular transfer will always take from higher temperature to a lower temperature, and it will not get transferred from the lower temperature to the higher temperature. This is in accordance with the second law of thermodynamics. What does it state? It states that it is impossible to transfer the energy from a lower temperature to a higher temperature. Okay, so uh, heat transfer is a science which deals with the flow of heat energy from higher temperature to a lower temperature. Say, for example, if you take 100 degrees Celsius and 50 degrees Celsius, heat energy will flow from the 100 degrees Celsius to the 50 degrees Celsius, and it will not flow from 50 degree to 100 degrees Celsius. Okay, the study of heat transfer not only explains how the heat energy is transported, but also predicts the rate of heat transfer. So how much, at what rate the heat transfer is taking place. This also can be predicted. Okay, suppose if you take water, okay, and if you are heating the water, it gets evaporated, and if you have a vapor and if you are cooling it, what will happen? It will try to condense. Okay, but the amount of heat transfer in both the cases is same, but the rate of heat transfer, you see, the rate of heat transfer is different. Okay, so the rate of heat transfer is different, but amount of heat transfer in both the cases are same. Okay. Now let me explain the difference between the heat transfer and the thermodynamics. What is heat transfer? As I told you earlier, that it is a transfer of heat energy from higher temperature to a lower temperature, and this deals with the system that lacks equilibrium. But thermodynamics, on the other hand, it deals with the system which is in equilibrium. It may be used to predict the amount of energy required to change a system from one equilibrium state to another state. So that means how much energy is required to change from one equilibrium state to another state, but it may not be used to predict how fast the change will take place, since the system is not in equilibrium during the process. In extremes, it is at equilibrium, but in intermediate, while at that time it is not in equilibrium. So you cannot predict anything in the between stages. Only at the ends it is possible. Okay. Now, what are the three types of matters? So one is the solid, second one is the gas, and third one is the liquid. Okay, so I have shown a figure here. You can see that the solid the molecules are tightly packed. In the gas, the molecules are very loosely packed, and in the liquid it is of intermediate level. Okay, whenever there is a change in the phase occurs, what happens? A large amount of energy is involved in this transition. Okay, so now we are going to go in detail about the modes of heat transfer. What are the three different types of modes of heat transfer? Okay, first one is conduction, second one is convection, and third one is radiation. We are going to see in detail about the three modes of heat transfer: conduction, convection, and radiation. Now, what is meant by conduction? Conduction is the transfer of heat in a continuous substance without any observable motion of matter. Okay, conduction is the transfer of heat in a continuous substance without any observable motion of the matter. Say, for example, you take a solid rod and you heat the solid rod at the one end, and you feel the hotness in the other end. The transfer of energy is due to the conduction. In this mode of heat transfer, we cannot see any motion of matter, but energy is getting transferred. It is because of the conduction. How it gets transmitted? Because a transfer, whenever you supply the heat energy, molecules take the energy and it starts vibrating due and due to the vibration it transfers the energy to the subsequent molecules, and from there it gets transferred to the subsequent molecules, and the energy is getting transferred in this way. Okay, so I have shown a schematic here. You can see that a rod is placed and it is getting heated up. So you can see that atoms and the molecules are getting heated up, and once it gets heated up, what happens, it starts vibrating. So due to this vibration the energy is getting transferred from one atom to the other atoms. Okay, and the conduction also can take place even in the stationary fluid. The fluid can be of solid, or it can be of fluid can be of liquid, or it can be of gas. Sorry, liquid or gas, liquid and gas, but both but the fluid should be essentially stationary. It should be in a stationary phase. It should not move. You should not there should not be any motion. Then only the conduction takes place. Okay, if we are able to see a macroscopic particle or a fluid moving, then that particular mode of heat transfer is called the convection. Whenever a macroscopic particle of a fluid moves from a region of hot to the cold region, it carries with it a definite amount of enthalpy. So such a flow of enthalpy is known as convection. So whenever you have a movement of fluid and the energy is getting transferred in that movement of in the fluid, then it is called the convection. And this particular convection is classified into two types. First one is the natural convection and second one is the forced convection. The other name for natural convection is called the free convection. Let us see what is the difference between these two types of convection. First one, the natural convection. The movement of fluid particles is due to the buoyancy force generated due to the density difference of heated and colder region of the fluid. Okay, let me explain this with the figure. So here in this slide there are two figures. First one, the A figure is for the natural convection and B is for the forced convection. The natural convection is also known as free convection. Okay, so there you can see a beaker and you have some water and the heat is supplied. So what happens as it is we are heating the big solution, or you can say water. So the water molecule very closer to the base surface is getting heated up. What happens? It gains the energy. It gains the energy, and the molecules are getting loosened, or you can say that the molecules are trying to move freely and trying to move freely. That means it is trying to form a vapor. So the density gets reduced. As a result, what once if the density reduces, what happens, this density the molecule which is at the bottom try to raise, and the denser molecule which is in the top try to move down. So this is because of this buoyancy force, this molecules moves to the top, and this type of heat transfer is called the natural convection. So it is mainly due to the density difference and caused due to the buoyancy forces. Okay. Now coming to the forced convection. What is meant by forced convection? Movement of fluid particles from the heated region to the colder region is assisted by some mechanical means. Example, stirrer. So in this B figure, you can see the same beaker with the water, and you have a heat source here at the center, and in addition to that you have a stirrer which is at the center, which tries to help in the mixing. So what happens, yeah, in addition to the natural phenomena, we have a stirrer, or you can also say that as an agitator here. So this helps in heat transfer. So this type of heat transfer is known as the forced convection. So this can be stirrer, or even you can use an agitator also. Okay. Now the third mode of heat transfer, radiation. So thermal radiation is the term used to describe the electromagnetic radiation. which is observed to be emitted by the surface of a thermally excited body. Any thermally excited body can emit the radiation. So it need not be very higher temperature. It can be even at the room temperature also. It can emit the radiation. This is the only mode of heat transfer which can transfer even without any medium. There is no requirement of medium for this particular type of heat transfer. Even in the vacuum mode, this mode of heat transfer is possible. The example for this case is the sun's energy. Okay, there will be a continuous interchange of energy between two radiating bodies with a net exchange of energy uh, from the hotter to the colder body. Say for example, if you have one hotter body and one colder body, there will be a radiation continuous interchange of energy. That means from here to here the energy will transfer, and at the same time from here also to this point the energy transfer will take place, but the net exchange will be also from the higher temperature to the lower temperature. Okay, this is the third mode of heat transfer. And for example, if you have an heater, and if it is operated at higher temperature, you can also feel the hotness when you are sitting far away also, but you can see that he is getting the heat getting heated up through the radiation mode of heat transfer. Okay, um, up to this I will take taken. Okay, uh, thank you.